Hello, this is a quick outline of outliers, a quick description of some things to think about when we're looking at outliers and for outliers in our data set. So when we talk about outliers, we observe responses that are oddly out of place. Some responses are distinctly different or odd, if you will, or when you look at two variables together, they together form some odd relationship with each other. And so the question is the observation outside of the population of interest, or is it so extreme or so rare that it does not represent reality? And does it impact your data so much that it contaminates or misrepresents what you should otherwise think is happening in reality? So is the observation or response representative of the population? That's kind of what we want to think about. And why does this occur? So is it a naturally occurring type of a thing, or is it a result of some procedural error? Like, for instance, was something coded improperly and then put into the database? Was there some extreme event or unforeseen or unusual event that happened that caused some of the respondents to be way out of the norm? And would that extraordinary event not be representative of what we would typically expect to happen? Um, or is there some unique combination of values or combination of variables that is odd that would not be expected? So basically we're looking for oddities in our outliers, oddities in our data, and what would explain those oddities, and that might be cause or rationale for dealing with an outlier. So much like with missing data, it's very rare to eliminate a case or a response. And you want to be very careful about taking data out or dropping data very freely or capriciously. You want to be very careful about doing this. So even though something may appear to be an outlier, I would use a lot of caution before actually dropping them from. Okay, so as we want to deal with these outliers, we need to identify first where the outliers are, and what would constitute an outlier. So if we have an individual variable, one of the things we can do is we can standardize the data, standardize the variable. And when we standardize a variable, what we do is we standardize it so that the variable's mean will be 0 and its deviation, standard deviation, will be 1 with the data set. And the way we do that is we compute the z-score for each response, where we take the individual's response, multiply or subtract from it the mean of the variable, and then divide by the standard deviation, and then that'll give the z-score or the standardized score for that particular variable. So when we look at that score, if we notice that score is really large or really very far away from 0, then we know it's very far away from the average or standardized score that we would expect. So after we standardize the data, if we look at individual cases with scores between or above 2.5 and 4, depending on if it's a small or a large sample, then those would be cases that we would think might be outliers. Okay, so those would be ones that are really outside of the norm. They're very far, that score has been standardized, so it's very far away from 0. So that would be something that we would be concerned about. Okay, so that's what we want to think about again. For standardize the variable, and then consider outliers that are beyond 2.5 to 4 or above in terms of overall scores. Okay, so to standardize, subtract the observation value from the variable mean and then divide by the standard deviation. All right, so then another way to look at this, that's for an individual variable, but another way to consider outliers is their relationship with multiple variables. So if we have two variables that work together, or that we think go together or whatnot, and we have a case where the variables that are viewed together are way out of whack or out of the norm, then that's a consideration or a problem that we want to think about. One way to do this is to start looking at scatter plots. So a scatter plot would be a graphical depiction of the relationship of two variables, and you should see the actual responses kind of grouped together, but then every once in a while you'll see a response that's way outside of the grouping. And so the scatter plot then will be able to tell you an illustration of what might be an outlier or what variables you might want to consider as an outlier there. The other thing that we look at when we deal with multiple variate considerations, like if we have lots of variables together, like in a regression or something like that, then there may be a case that is abnormal, and that abnormal case would be an outlier. So we have an individual variable that could be that could indicate a respondent as an outlier. We could have where we have two variables that should behave similarly across all of our respondents, yet we may have a respondent in which the two variables have an odd relationship. Or we could have a model with lots of variables together, and again, we may have a respondent that is way outside of the norm, that doesn't behave naturally, and that could be an indicator of an outlier too. So we have three different levels of outliers depending on how we look at the variables as a single variable, two variables together, or multiple variables in a multivariate approach. Okay, so the Malahonobis d-squared test is what we think of and is possible to use when we look at measuring in a multivariate analysis. And again, this is a test or a score that we can call for within SPSS, and we can measure to make sure that it is within the range. So the Mahalanobis d-squared divided by the number of degrees of freedom should give us a measure, and the value that we would look for would be between 2.5 and 3 to 4, depending on the sample size. So we'll look at those a little bit more closely in some other lectures, in terms of describing these and walking through, again, the process of looking for these. At the end of the day, however, you need to decide whether you're going to delete variables or delete responses because they're outliers or not. And again, I would be cautious about deleting data unless they really contaminate your results and they are clearly not representative of the population, or you know that there's some type of error that has been made, like in the inputting of the data or something along those lines. So, and then we have to deal with it, because if you're going to eliminate it, then you're going to deal with a missing data point. And so you want to think about the ramifications of creating missing data in that case. Okay, so this has been a very quick and to the point discussion on outliers and univariate, bivariate, and multivariate approaches when we think about how we want to deal with outliers and what to look for.